I'm Greg Garbos of Four Season Tools. We're here at City Bitty Farm in the headquarters of Four Season Tools in Kansas City, Missouri. We're out in our stationary high tunnel or greenhouse, and we're going to be talking about benchtop radiant heating systems. Specifically at this operation, we're focused on microgreens. In front of me are several different microgreens that we're going to be growing year-round, from peas, arugula, Tokyo bacana, red cabbage, amaranth, and radish. To be able to heat these wonderful microgreens and grow them year-round, there are several options. A lot of high tunnels use forced air, where they have either natural gas or propane and have a large heater that's just blowing hot air inside of the structure. What we're working on is a much more efficient radiant heating system, where we're using hot water and basically heating all of our crops from underneath. We're going to be growing 4 seasons so that we can keep that great product available to our clients year-round. We don't have to have our clients just for a part of the year. And it also allows us to have a marketing advantage of having crops in the off-season when other people don't. Sometimes people refer to winter farming as farming the backside of the calendar. Behind me are some of the components that are part of this radiant heating system, and I want to talk about how it works. Any radiant heating system will use hot water. In our case, we're using hot water that comes from a hot water heater. At this specific location, we don't have propane or natural gas, so one of the best options for us is to use electricity, and we're going to be using that electricity to heat hot water. In the far corner of the greenhouse, we actually have a short electric hot water heater that's 220 volts that can tuck nicely underneath the benches. It's about 30 gallons, and we think that's going to work great for our scenario. It does have 2 different heating elements. There are different ways to use the heater to get additional heat out of it, but we're going to be using it right as it came out of the box. When you're using hot water, you basically are running that hot water through a closed loop system. The hot water that comes out of the tank, we call that the supply side. The supply side is the hot water from the tank. Then we have the return side, meaning that hot water has already gone through our radiant system and coming back into that tank to get heated again. In this particular situation, we have a rainwater capture system in our greenhouse, so we're able to switch between rainwater inside of our radiant heating system or city water. Since I want to be able to use that hot water for more purposes than just the radiant system, we're also going to be able to get hot water out of that system in a garden hose, and we've installed a sink to get that hot water out as well. If it's a closed loop system, you just got to make sure that if there's ever any leaks in the system, that you replace the water inside of that system. For us, if we take hot water out of the system, we need to make sure that we put cold water back in the system. So what we're going to talk about now is some of the different components to pull off this radiant heating system. We're going to start with the supply side. The supply side basically has different components than the return side. It's important that these components come on the supply versus the return side. The way that we've decided to create this system is to actually sell these as modules. So what I'm holding in my hand is a supply module. So we have a plumbing union to disconnect it easily on both sides of this hot water union. We've got a temperature gauge to see the hot water temperature coming out of the tank. We have a way to get the hot water out of the tank immediately. We've got a check valve to make sure that everything goes in the right direction. This is only a one-directional valve. And then we have an air valve here, so if we ever need to purge the system, we always want to try to gravity drain all the water out of the system, but we also can use compressed air to force that water out of the system. Then we come in, and it goes into the rest of it. After the supply module, the next module that we have, I call the air scoop module. So what this does is it makes sure that air gets out of the system. Again, we've got unions on both sides of the system, making it easy to service and to replace. This big box right here, this basically air needs to be upright. The air will go through this system, and it's got a little bump out on the top. So as water's going through it, any air that's in the water has a tendency to collect on the top, and then there's an air vent on the top of this system. So as the water's going through, air will collect in this little bump out on the top, and then this air vent allows us to open this as we need to. This air vent doesn't need to be open the entire time. You just open it when you need to purge the air out of the system and any other time to get air out of that system. So again, this is basically the air scoop module. After that, what we have is our pumping module. It's in pieces right here, so I'm not going to pick it up. And this can be sold as either a single pump module or a redundant pumping system. In this case, we have a redundant pumping system. Since we're growing microgreens, which are high-value crops, we never want to be in a situation where at 4 a.m. or 3 a.m. on a cold night, one of these pumps fails, and we're going to lose that heat inside of our greenhouse. So what we've done is we've basically doubled up on our pumps, and we have the ability to easily switch between the 2 pumps. These are Taco recirculation pumps, and one of the things I like about these pumps is that they have a cartridge system, meaning that any of the mechanical parts inside of the system can be serviced very easily. So the pump motor might still be working, but basically the centrifuge, or whatever that part is called inside of this, if it fails, we're able to take a couple bolts out and just replace the mechanical parts of that system. So what we do is we come in, again, we've got a union to union, so this whole entire thing can be serviced as a module. The water comes in, it splits into two things. We've got two redundant pumps, and then we've got the wiring set up right here with a three-way switch, so that basically we can switch between one pump and the other pump. Then we've got two different valves. It's important to have valves in the redundant pump system. That way if the water comes in and one of the pumps fails, we can shut off one side, flip the switch, and then go to the other pump. If there wasn't a valve in this system, there's a chance that that water could just circulate inside of this loop. After you get through that, it then goes back out and goes into your radiant lines. Some other of the components actually drive the system. This is a temperature control unit. This unit can be used for heating and for cooling. There is possibilities to use these radiant systems for cooling as well as for heating. You can set the temperature in Fahrenheit or Celsius of your system. You can also set whether it's in a heating mode or a cooling mode, and then you can set your temperature differential. So for example, if I want my system to kick on at 36 degrees so that nothing freezes, what I can do is I can set this at 36 degrees and then basically say, set the differential at 4 degrees, meaning it'll always try to maintain that soil temperature between 36 and 40 degrees. Another part of the wiring of the system is actually a pressure switch. This pressure switch here is what makes sure that there's no clogs in the system and there's no major leaks in the system. There are several different pressure switches involved or available. I definitely like the pressure switches that have an on, off, and also have a start function. There are two ways to run this system, where you can externally pressurize the system, or you can get a pressure switch that allows the system to pressurize itself, which I think is a great feature and barely adds to the cost of the structure, of the system. After this water goes through this, it's going to go into your benches. What we have right here is we have integrated shelves built into our greenhouse. That gives us great space underneath. On top of that, we've got 2-inch thick insulated foam. This allows to make sure that as we're heating the radiant lines, that temperature is getting trapped and forcing the temperature up as opposed to down where there aren't any plants. Inside of this, we've used a router, and we've gone ahead and we've routed out different lines inside of this system. The system will be coming in from the end behind me, so what happens is each one of these lines comes out, gets to the far end, it loops around and comes back. So there's a kind of a hot, and there's a return even within the actual loops inside the system. This right here is an example of the radiant line that is going to be used and set inside of this insulation. It's got an 1/8 inch inside diameter and a 1/4 inch outside diameter, which are really convenient dimensions. It's very flexible, which allows us to make turns in the system. The other thing to point out is when we install this, we're going to do something called a service loop. So even though we've got it all the way inside of our bench system, we're going to go ahead before we get it into our PVC plumbing, and we're going to put a loop inside of that radiant line. That way, if we ever need to service this, or if we ever get a hole, we can cut that hole out, put a coupling in without having to waste the entire line. That service loop gives us just enough length that we can go ahead and service that without having to replace the whole entire thing. You can see that these things come on big reels, and you're going to use a specific type of drill bit when we connect this system back into our PVC piping. There are couplers, elbows, T-fittings, and little clamps that work with the different fittings that are all available for this radiant lines. So, after we've come in on the supply side, we've gone through our air scoop module, gone through our single or redundant pump module, gone through the radiant benches, and then we come back towards the hot water heater. What that does is then brings us to the return module. This is all the water that has already gone through the bench system and it's on its way back into the hot water heater. Again, I've got the ability to get the water out of the system, and I can also put water into the system. So since I've got rainwater capture, this is where I'd actually put the water into the system. So the first thing that I'm doing is I'm filtering that water. So we've got a filter right here that's actually a 130 micron filter. It's a mesh filter that can easily be taken off and cleaned if we need it to be. And that way I can put water in the system if I'm taking hot water out of the system. So I get water in, I've got my filter, and then it comes up, and then what I have here is two gauges. One is the return temperature, so I know how much temperature has dropped inside of the system. And then I also have here the return pressure. I want to make sure that my pressure gauge is on the opposite side of my pumps. That way I can see what pressure is actually making it through the system. What you'll see on the bottom of this is there's actually a little T-fitting right here. This is actually where that pressure gauge goes. So the pressure gauge that starts and stops the system is also as far away from the pumps as possible. Then it goes up and it goes into my hot water heater. Some other things to talk about is when you're running this system, you have to be careful to get all of your fluid pressure correctly which systems get the hot water first and which systems you take the return water back from first. So the first bench, say this is my first zone, my first bench to get hot water is my last bench to get the return from. So if I only have 2 zones, and this is the first bench to get hot water, this is the second bench to get hot water, my return water will come from my second bench first, and then it'll come from the original bench. It's called a reverse return. So you always want to make sure that the return is actually coming last from the first bench that's heated first. Hopefully I described that adequately. The other thing we want to talk about is the interaction with our hot water heater. There's a lot of different ways to supply hot water into this system, from geothermal to propane or natural gas hot water heaters to solar hot water panels. For us, we're using a hot water heater. So what we have here is some of the different plumbing fixtures that will be attaching to our hot water heater. We have a supply and a return that comes out of our hot water heater, and then there's also a pressure gauge. The typical pressure gauge that comes with a hot water heater is designed for residential water pressure. That is way too much for this low pressure system that we're going to be working with. This system is going to be running at something like 12 to 15 psi, really low water pressure. We still need to be able to have a pressure release valve, so as we heat that water, if it creates too much pressure, we can get that pressure out of the system. So one of the things that we're doing is we're replacing the pressure relief valve on the hot water heater with another one. This one right here is rated for 30 psi, and that makes sure that if the water pressure builds up too high, that we're able to blow that pressure off of the system. Another thing to just be mindful of is there's some gaskets inside of this system. For example, all of our unions that we're using, these different unions have gaskets inside of them. There's different types of ointment you can use to prolong the life of gaskets, and that's definitely a good idea. And then also between the taco pump and the flanges, and there's different flanges available for different applications, there's also gaskets inside in between those systems. So it's important to service your gaskets and handle them properly. So our hot water comes out of the hot water tank. It goes through the supply module, the air scoop module, the pumping module. Then it comes back, goes through all the benches. We're going to use the reverse return to get the water in the correct order back from the benches. Then when that cold water comes back in, we're going to go ahead and we're going to put it through the return module and then into our heating source. So our goal is to actually mount all of this underneath our benches so it's compatible with our benchtop heating system. So you can see this is designed in such a way where all of our gauges are really easily readable. So if we imagine that the hot water heater is below where I am right now, we're going to tuck all of these different gauges right underneath the bench so that I can see everything in one place. You also want to be mindful that with hot water, when you're getting water out of the system, that you're making sure that that hot water is coming out in a way that you don't have any risk of scalding somebody. This is hot water, and you don't want to hurt anybody, so you will notice that even though my gauges are facing towards me, all of the places where I can get hot water out of the system are actually going underneath my benches. I don't want to be in a scenario where hot water can basically come right at the person standing in front of the system. I also have to be mindful that the hoses that are coming out of the system, the air hoses coming out of that system, that we don't want them in our walking paths. So when we sell this system, we basically sell these as modules from the union to the union, and then we don't glue anything together. So if you want to do any modifications, you've got the ability to do it, and also make sure that you glue everything properly and that you can pressure test it. The other thing that's worth noting is that if you do need to replace one of these modules, a really simple way to make sure that you don't leak out of the system is to take a union and put a cap in each end. So if you imagine that this air scoop module is plugged into the system, I need to take it out. What I can do is break both of these unions, take these 2 end caps, put the end caps in between this system and the remainder of everything so I can keep all of that water into the system. When you're servicing it, it's probably a good idea to go ahead and put compressed air into that system to purge all that water out. And as you're plumbing your system, it's also important that any of the low points, I would go ahead and put in a valve or something, or a spigot, some sort of way to get all that water out of the low point of the system. It's very important that if you ever allow the system to freeze, you get all of the water out of it before it freezes, because as water freezes, it expands and it can cause a lot of damage. You also notice that all of my fittings here are white. These are Schedule 40 fittings. These we were using for this prototype system. They're kind of a low-grade fitting. There's a kind of a darker gray fitting that you can get that basically is a Schedule 80 fitting, and those will last a lot longer. Some of the fittings are prohibitively expensive. In order to get a 40 versus a 60 schedule, for example, the check valve is something where the price difference is like $20-something between a Schedule 40 and like $100 and something for a Schedule 80. So a lot of people that I know that have made their own radiant systems like this, they go ahead and they get Schedule 80 for all of their fittings, and then they'll use Schedule 40 for their runs. This is our prototype system. A lot of different changes are coming. as we develop the system and try to get it in. We're really happy with what we've got here. We're about to install this system and kind of work through all the different benefits, but we're hoping that the amount of energy that it takes to heat our greenhouse using a system like this will be dramatically less than what you're going to need if you're using forced air and propane or natural gas. The other thing that I should mention is that we're going to be heating our benches and our crops, but not necessarily the entire structure. So I know people with a similar system to this that actually allow their greenhouses to freeze, and then what they do is they make little low tunnels or little mini greenhouses where all their crops are going to be. They make sure that their greenhouses or their little mini, their low tunnels don't freeze, and their greenhouse could freeze, and they're just making sure that the crops are okay and not putting that energy inside of the greenhouse. For me personally, I think what I'm going to do is keep my greenhouse at about 36 degrees with this system, and again, I'll be using low tunnels either through remay or row covering or through greenhouse plastic, so that at nights when it's really cold, I'm actually trapping all of that heat inside of these low tunnels and not heating my entire greenhouse. It's also important when there's a lot of money associated with some of the crops that you have inside of these greenhouses to be thinking seriously about redundancy. In our example, our hot water heater has 2 heating elements in it and 2 thermostats. Therefore, if either one of those ever failed, the system still should be able to limp along on one. As I've shown you here, we're doing redundant pumps so that if one of the pumps fails, I can also continue to use that system. I'm also having a backup completely independent of my radiant system, where I'm using some of those bazooka heaters, some of those tube heaters hooked up to propane cylinders. I've also heard people using kerosene, but to have an independent system that can be thermostatically controlled. So if I keep my greenhouse at 36, I might have a backup system that would kick in at 33, 34, 35 degrees. So if something ever fails with this system, I make sure that I don't lose the crops inside of the system. We're really excited to get this thing going, and we'll have some more videos coming that talk about how to actually install this and how the whole system works.